Calls for systemic approaches have become increasingly common in the analysis of agricultural and food systems. Yet the meaning of this expression often remains vague. Does it simply mean taking more factors into account, using models, working across disciplines, or something more specific? This module aims to clarify what a systemic approach actually entails, both conceptually and in practice. I am Philippe Barret, Professor of Agroecology and System Analysis at Université de Louvain, and together with Louis Tessier, researcher at ILVO, we will present that first module. We begin by introducing the core principle of system thinking and by asking what makes an approach genuinely systemic. From there, we move to the practical question of how such a perspective can be applied in research. For instance, through tools that help represent interdependencies, feedback loops, and lock-ins within agricultural and food systems. The module then shows that applying a system approach quickly raises further challenges because food systems involve multiple scale, diverse actors, and intertwined environmental, economic, and social processes. System thinking almost inevitably requires interdisciplinarity. By the end of this module, you will be able to explain what distinguishes a systemic approach from a linear or reductionist one. Second, identify key systems concepts such as interaction, feedback, emergence, and boundaries. Thirdly, distinguish between major families of systems methods. Explain why food system analysis requires interdisciplinarity and attention to scale. And finally, reflect critically on the participatory and normative dimensions of system thinking for transformation. Overall, the modules move from the basic question of what a system approach is, to how it can be used, to why it requires interdisciplinarity, and finally, to why food systems transformation also calls for participation and reflexivity. We begin with a basic but important question. What do we actually mean by a system approach? In discussion of agricultural and food systems, the term is often used very broadly, sometimes simply to mean that the situation is complex. But system thinking means something more precise. This first unit, therefore, introduces the core principles of a systemic approach and clarifies what distinguishes it from more linear or reductionist ways of analyzing food systems. To approach an agricultural system, one first tends to think about production, what happens in the fields. However, the production does not exist in isolation. Its function is to meet consumption needs. A fundamental link is therefore established between production and consumption. This link takes the form of a flow of products from production to consumption. In a market society, the continued flow of product is ensured by a monetary flow in the opposite direction. When we broaden the perspective, additional flows become visible, including energy, materials, waste, and information. These flows are embedded within broader levels of organization and regulation that frame the food system. As a result, such systems can exhibit a high degree of complexity. Taking a system perspective, then, is understanding that food systems are composed of a diversity of interacting elements. These elements are not merely coexisting. They are interconnected and oriented towards specific purposes. In general terms, a system can be defined as a bounded set of interrelated elements whose interactions are organized in such a way that they form a whole with emergent properties. This definition highlights the importance of a systemic approach to agricultural and food systems. Such an approach is essential for understanding system dynamics, supporting decision-making processes among stakeholders, and providing a relevant analytical framework for multi-level transitions. A systemic approach rests on several key principles. First, attention must be paid to elements in interaction. Second, and more fundamentally, attention must be given to the interactions themselves, rather than to elements in isolation. Third, these interactions can produce nonlinear dynamics and emergent properties at the level of the whole. Fourth, a systemic approach requires engaging with the complexity of the phenomena under study, rather than artificially reducing them to isolated variables. Finally, because not all possible relations can be included, system thinking necessarily involves boundary judgment about where one system or subsystem begins and ends, what lies in the environment, and what is to count as relevant to the inquiry. By analogy with the famous painting by René Magritte, "This is not a pipe," one could say this is not a systemic approach when a black box model is used merely to link an input to an output. In such cases, one may obtain a certain description, for instance through correlations or regressions. One may even be able to predict, but not to truly understand. Understanding requires entering into a logic of decomposing the system into different elements, and of analyzing the connections between these elements. This choice implies first defining the boundaries of the system under study. Within these boundaries, one can then identify the different elements and the interactions that connect them. It is also at this stage that feedback loops may emerge, which will be discussed later. Once this framework is established, it becomes necessary to examine more concretely what constitutes in practice an agricultural and food system. The first unit has shown that a systemic approach is not simply about considering many factors at once. It is about analyzing a bounded whole made up of interrelated elements, whose interactions generate broader dynamic and emergent effects. But once we adopt this perspective, the next question becomes practical. How can such interdependencies, feedbacks, and dynamics actually be represented and analyzed? This is the focus of the next unit.